Hi, today we're going to talk about the quotient properties of exponents. And our essential question is, how can I simplify expressions using quotient properties? So first one we're going to talk about is the quotient of powers property. Okay, so that's when we are dividing powers with the same base, we actually subtract the exponent. So here's the algebraic example for that. If you have two different powers being divided, so within a fraction, and they both have the same base, like in this one we have a raised to one exponent divided by a raised to a different exponent. What we do is we just simply subtract the exponents to get the new exponent. Here's a numeric example. 6 to the 7th power divided by 6 to the 4th power. Notice both bases, both powers, have a base of 6. So what we can do is, as we try to combine those, we just subtract the exponents to see how many are left, and we get 6 to the 3rd power. So why does this work? The reason why this works is because if we take this example, 6 to the 7th over 6 to the 4th power, and write this in expanded form. So in the numerator, I'd have to have 6 times 6 times 6 times 6 times 6 times 6 times 6. I think I said it 7 times. If not, I meant to. And in the denominator, I have a 6 multiplied by itself 4 times. So there's 6 to the 7th power divided by 6 to the 4th power. And we know from simplifying fractions, if you have the same factor in the numerator and in the denominator, it cancels out because anything divided by itself is 1. So when we have a factor of 6 divided by 6 equals 1, we can cancel that out. 6 divided by 6 equals 1. 6 divided by 6 equals 1. 6 divided by 6 equals 1. And what we're left with then is 6 multiplied by itself 3 times. In other words, 6 to the 3rd power, which is, I believe, 216. So just think about what happened there. When we write it out, when we expand it, where these numbers represent how many of those factors appear in the numerator and in the denominator. And because of how we simplify fractions, we're actually canceling or getting rid of the extra ones from the denominator. Okay, so getting rid of, or another way of thinking of it is taking away, implies that we need to subtract the exponents to show that. So again, we started with 7 of those 6's in the numerator. We were able to cancel out 4 with the 4 6's in the denominator, and that left us with 3 of the 6's multiplied together. So 6 to the 3rd power, or 216. Let's take a look at a few examples. Now in number 1, we have 3 to the 8th power divided by 3 squared. So we are working with a base of 3 on the top and the bottom. So in terms of being able to cancel things out, we know that we do actually have a bunch of 3's in this problem. If we were to expand this, we'd have a total of 8 3's in the numerator. 1, 2, 3, 4, 5, 6, 7, 8. And just 2 of those 3's in the denominator, 3 squared. So how many can we cancel from each? Well, we can cancel out a 3 and a 3, since 3 divided by 3 is 1. And then another 3 and a 3, because 3 divided by 3 is 1. And while we started with 8 3's in the numerator, we were able to cancel 2 of them out. And we're going to be left with just 6 of those 3's in the numerator. So the math behind it here, we want to show using that property, that all I have to do is subtract 8 minus 2. And here's my visual for that. I had 8 of them up top. I subtract or take away 2 of them because I cancel with the bottom. 8 minus 2 is 6, and 3 to the 6th power is 729. Our second example, we have x to the 5th power divided by x to the 5th power. So if we use our property, we know that, okay, well, we're dividing x's by x's, so that's good. We can use our property. All we have to do is subtract the exponents. Since 5 minus 5 is 0, we get x to the 0 power. And you remember what that equals? Anything to the power of 0 equals 1. I love this example because it also shows why something like this would have a value of 1, why x to the 0 power is 1. If I were to write this in expanded form, x times x times x times x times x in the numerator, and then x times x times x times x times x in the denominator. Remember our rule, we can cancel out any common factors in the numerator and the denominator. So I can cancel an x with an x, a second x with a second x, a third x with a third x, a fourth x with a fourth x, and a fifth x with a fifth x. And basically everything cancels out. There's not any x's remaining. That's why it was x to the 0 power. And why was it 1? Well, because anything divided by itself equals 1. So x to the 5th power divided by itself is also just going to equal 1. All right, let's look at our second quotient property. This one's called power of a quotient property. And it reads that a quotient raised to a power, so something like this, so a quotient or a fraction really, raised to a single power is the same as taking the quotient of each base raised to that power. So a to the nth power, b to the nth power. It's essentially distributing again that exponent, but this time we're distributing it to each part of the quotient. All right, so we did have one like this with product properties where we distribute the exponent into the parentheses. It's kind of the same thing. Both the numerator and the denominator get that same exponent. So here's an example with numbers, kind of explaining why this works, how this works. So if we have a fraction like 3/5 and it's raised to the 4th power, we know that that 4 means I'm multiplying 3/5 4 times. So 3/5 times 3/5 times 3/5 times 3/5. Now the way that we multiply fractions together, you might remember, is you just multiply across the top, so 3 times 3 times 3 times 3, and also across the bottom, 5 times 5 times 5 times 5. Well, another way to write 3 times 3 times 3 times 3 is 3 to the 4th power, and another way to write 5 times 5 times 5 times 5 is 5 to the 4th power. So we get 3 to the 4th power over 5 to the 4th power. We're just distributing the exponent of 4 to both the numerator and the denominator. So in number 3, to see how this works, 3/4 to the 3rd power, just like we saw in that previous example, if we wanted to write this out, I just have to show that it's 3/4 times 3/4 times 3/4. So there's 3 of them because my exponent was a 3. Well, knowing how we multiply fractions together, it would be 3 times 3 times 3 in the numerator and 4 times 4 times 4 in the denominator. In other words, 3 to the 3rd power over 4 to the 3rd power. And because they are values here that we can actually simplify this, we would multiply it out. So 3 to the 3rd power, I believe, is 27. 4 to the 3rd power is 64. So 27/64 would be our answer there. All right, finally, number 4. This incorporates a lot of different properties that we've been working on over the course of this last week, including a quotient property, because we have a quotient being raised to a power. So we have 2x to the 3rd power over y times z is all being raised to the 3rd power. Notice that this whole fraction, everything inside the parentheses is grouped together and raised to the 3rd power. So the first thing we're going to do is we're going to apply this rule of what does this exponent on the outside mean? And we're going to have to make it so that the numerator is cubed and the denominator is cubed. So what that looks like is I take the numerator and I still have to group it because that's 2 different factors there, is cubed. Same thing with the denominator. It's not just the z that's cubed, it's the y and the z together. So now what we're going to do is use a property from earlier this week. It says we're going to distribute this exponent into both the numerator and the denominator. So for this 3, I want to make it, well, it's not just 2 times x cubed and then cubed, it's each part cubed. All right, so it's the 2 gets cubed, the x cubed gets cubed, like this, x cubed cubed. And then even in the denominator, we split the y and the z up, and they both get the exponent of 3. So y cubed, z cubed. All right, so we see that we don't have any common bases here. We've got only one power that has a 2, one power that has an x, one power that has a y, and one power that has z. But we do have a few things in the numerator that we can simplify. 2 to the 3rd power, well, 2 times 2 times 2 is 8. Careful, it's not 6, that's 2 times 3. We're doing 2 times 2, which is 4, times another 2, which is 8. And then x to the 3rd power to the 3rd power, this is power of a power from yesterday, or Wednesday for those of you that have Friday class. We just multiply those exponents. Okay, so that's going to be x to the 9th power. So on the numerator, we have 8 x to the 9th power, and then the denominator stayed the same, y cubed, z cubed.